everybody. Can everybody hear me? Right on. Really a pleasure to be here. I really like this venue. It's like a silent disco, so I appreciate that.
Thank you.
And again, everybody can hear me. Okay, great. So before I start, can I just get a show of hands? Who here is in a SOC team? Okay, a few people, great. Who's a data scientist? Great. Okay. And anybody on like the data engineering for SOC teams or anything like that? Okay. Anybody else I missed? Okay, good. Well, it's a pleasure to be here. My name is Alexander Maurice. I used to be a theoretical physicist, and then I moved over to AI. It's this very similar mathematics. Today I'm going to be telling you guys about how Graphistry won the US Cyber Challenge using graphs and graph thinking. So a little bit about Graphistry. Graphistry, does anybody use Graphistry here? Okay, great. So this is going to be a great introduction and hopefully something that everybody starts using afterwards. Graphistry is a GPU visualization analytics suite that also has baked in a full AI suite into it as well. It actually started from work that the technical founder, Leo, worked on in grad school. He was obsessed with crunching through huge amounts of data, using GPUs, and actually using it way before it was cool. So that work led to early innovations in the Rapids ecosystem, which led to Arrow and eventually NVIDIA. So all of his that group of people that he matriculated with went on to do some really incredible things. So it's an incredible honor to be actually working with this guy. Graphistry allows you to do all types of investigations. You can throw in your messy data frame and get back answers very quickly, and I'll show you guys how. A little bit about some of our clients. We work closely with mission-critical systems in the US government and other types of governments. They use it primarily for cybersecurity and other types of things that I actually can't tell you guys about. But it's also used in a wide range of different industries. So everything from investigative journalism, data scientists in general, anybody that's doing textual-based data, you can now throw all that dirty data into it and then produce these knowledge graphs and embeddings really easily. So with the Cybercom challenge, does everybody know who Cybercom is? Okay, cool. Somebody here. So Cybercom is responsible for collecting and monitoring all types of mission-critical systems within the US government. They span everything from the cybersecurity infrastructure that builds out many of the systems that we use for national security. And they also touch different types of systems like the Navy and the Army. So what happened? Well, what happened was that they set up a surrogate honeypot in the Czech Republic, and they had many different types of attacks and models that happened against them. So for instance, like honeypots, malware, phishing. And what you can see here from this data is so interesting is that it really extends everywhere. So you'd think something as boring as a system in the Czech Republic would potentially have just a few attackers. There was actually attackers from all over the world here. And what I really find interesting here, I don't know if you can see my cursor now, is that there's basically servers all over the Bahamas. There's servers in all these unexpected places. So just being able to see that was already kind of a big win. And another thing you'll notice here is that the data on the bottom here is actually quite boring, right? It's tons of logs data. So if you are in security, that's sort of your bread and butter. As a data scientist, there's other data sets that maybe might be a little bit more appealing to people. But the question here is, like, how can we really take this data and turn it into something that's actionable? Now, on the what is it for you guys? On the left-hand side here, you see a snapshot of what that data looks like. It's a lot of source and destination computer connections. There's a lot of other metadata that I'm going to be glossing over right now. And one thing to understand is that this is actually, the data are actually correlations, right? Data itself, if I just give you a whole bunch of newspaper articles or whatever it is, if you read through them all, you would be able to understand and start binning things in a semantic context. So there's two types of correlations that Graphistry is able to do. One is explicit correlations, right, where you actually have link identifiers like IP addresses, categorical flags, things like that. And you can very easily then see the entire database at your disposal. Now, the second type is actually fuzzily linked behaviors. So this is the part that comes into the AI side of the spectrum. And what you can actually do now is use advanced AI techniques to take something that is a tabular type of data and transform it into something that actually has edges. So it has implicit edges between things. And we'll show how this actually won the challenge. So I'm giving you guys a sneak peek of that right now. So just to give you guys a sneak peek of what we did to turn this into a week or 2 week long investigation with tons of different notebooks, we're going to show you Louie right now, which is a way to basically speed run that exact same investigation, but within a conversational interface. So in this case here, Louie connects to all your data. And it connects to Databricks, Neptune, OpenSearch, Splunk, any Postgres that you have. And in this case here, I can ask it in natural language, get me the data from the alerts volume reduction data set, and focus on cluster 20, and then I get the data back. So again, this is data that many people in the security world might be dealing with. They'll use Splunk to query the data. In this case here, we're trying to make it so that people that are very good at thinking can actually do that same type of analysis within a, I hate to say it, but like a single pane of glass view of the data here. Now, after that, I'm going to ask Louie to basically featureize that data in a smart way and then project it down into a lower dimensional space so that we can actually see it as a graph. And I can just highlight a little bit here, go forward through it. And here it is. So now we've been able to produce this graph, and I'll show you why this is relevant once we actually go into the details of how this works. But very quickly, you can use the tool. You've clustered it now in a way that was AI-driven, but you can still then use all the histogram tooling and all the stuff that you're seeing here in the video to pivot on those categorical features or those columnar features that you're used to from a database. It's an incredibly useful tool for all types of analysis. If you have a column that is has timestamps in it, you can do this type of drilling down. You can look at events through time, and then you can cluster it. So great. Okay, great. So now we're going to take a step back. So who here uses Databricks? Okay, so good. So a lot of people are using Databricks here. Now, a lot of SAM teams, they'll use Databricks to have this sort of unified view, and that's an incredibly important step and one of the things that we all know and love about Databricks. Now, you can combine this with Splunk or Snowflake, so now you had one problem, maybe you have two or three now. But the point is now that you're using the system here to unify the views and reduce the noise between all the different systems that a security analyst uses. One of the great things is that Graphistry is actually a pip installable open source system, so you can actually just use it from day one within the Databricks notebook. Now, on the Graphistry AI side, what's really important is that through the Cybercom, when they gave us this huge chunk of data, it was so much data that it couldn't fit into a single machine, right? So one of the things that Graphistry does that's incredible is puts all that through a GPU. So you can actually crunch through these data sets at thousands of times faster than you would normally do. Many times, analysts that we work with have all these different UIs, and they really appreciate the fact that they can query a given database within Databricks, and then pull that straight into the Graphistry workflow, and then manage their SEM systems through that. Lastly, I mean, really, this is such a key driver to why we were able to win this is the fact that it was GPU end-to-end an end-to-end pipeline using KuCat. Now, KuCat is something that we open sourced. If you guys are familiar with Dirty Cat, do you guys know Dirty Cat? No. So Dirty Cat was something that came out of scikits, where they were trying to basically throw in dirty data frames and have it produce machine-readable features that you could use in machine learning pipelines. So we then took that and made it GPU, end-to-end GPU compliant. So we came very close to being able to run the whole thing within Louie. All the notebooks that we did for Cybercom, we were able to then transfer over to the domain in Louie. And it really comes down to getting down this GPU accelerated data frame so you can go through petabytes of data. And you can see here on the graph, there's an incredible speed up. So really, this is about exploratory data analysis, right? So when you work with teams, there is a notion in the cyber world of mean detection time to see an attack. And that is a very robust metric that you want to scale down to a very small number, so that you know that if an attack happens, that you can see it and then act on it right away. So, so traditionally, how do teams go about doing this? You have this modern EDA stack, which is an ETL pipeline. Maybe there's a group of people that work on that. Maybe if you're going to that next step where you're not just doing descriptive statistics, but you're actually producing machine learning models, you'll then have a training step that requires its own team many times. And then there's the inference step. So maybe now you want to put this model into production. Databricks helps with all these types of things, like the ML flow type characteristics for model building. But that tends to be another team in general too. And then there's the viz and data reporting and dashboarding that comes out of it. And of course, what we really want is over here, all together, where the team has one single view over this. So the way that Graphistry makes this easy is all of our ETL is basically that single line of code there, right? You just query the data frame, you get the data frame back from whatever the source is, Splunk or Snowflake or whatever it is, and then you pass it into the Nodes API, and then just training is those two steps there. So we've really gotten it simple. I should say that UMap and dbScan, of course, has arguments. You can do a lot of really fun pivoting. You can choose which columns you want it to featureize, different scalings. There's all this stuff that can happen. But essentially, that is the training process there. And that's happening in compute, in memory. Now, let's say that you query for a new set of alerts that are coming in. Well, now you can take that batch thing and use the fit object G, and then you can see that plot right away. So now you have a visual identification of the new batch of data, and we'll see in the next slide or two how this actually works. Now, I should also say this is just the stuff that's specific to what we did for US Cybercom, but we also do auto GNNs, so graphical neural nets, really popular. They won the most influential prize in AI in like 2019. We also have, we open sourced a query language called GFQL, super exciting. You can basically do Cypher style syntax within Graphistry, and that's all at the compute layer. So you can actually just get really complicated traversals over the graph and get those results back without having to actually query the database. There's a lot of other stuff too. And if you're interested, just come and see me afterwards. So how does this actually work under the hood here? For the data scientists here, we're taking basically the source and destination computer and any other metadata that we wish to include, and we're turning that into features that's on the right-hand side here. And you can see here that it's organized the features, the columns of that matrix, in a way that makes sense in some sort of semantic context. And this is all automatic. And I should also add that like any other data that you might have, this could be supply chain data, textual data, you can do the same type of stuff with. So I'm going to spend some time on this slide here. This is showing you a huge snapshot of the alerts that we got and the actual model that we trained. So what we were able to do is take in from the gigabytes and gigabytes of data that was there, we were able to take a small snapshot of that data and fit a model on it. And what happens is that everything that you're seeing in blue corresponds to the totality of the data. So I've taken every data point and I've projected it down into space. Then I've treated everything that's green and red as a mini batch. So this is now me taking in a set of alerts. And now I've projected that down and I've tried to make the dots a little bit smaller so you see that there's a blue outline, right? So there is this island of this was the total amount of data versus what's coming in there. And what's incredible is that the red dots are the bad guys. And as you can see, what's happened in this featurization, AutoML featurization and UMAP trick, which was quite unexpected. We tried a lot of different things. GNNs, we tried different types of SecBERT, if you guys know about SecBERT. We tried a lot of different types of encoding, and the best one was actually just using simple topic modeling. And what you're seeing here is that every different red dot corresponds to a different type of behavior. So what's happening here is that we're able to not only get a correlation ID, so for instance, we start seeing some scans happening, then we start seeing some logins and repeat logins. And they occur over the same URL, IP addresses. Now what we can do is we can correlate those two together. Once we have that correlation ID, we can actually turn that into an incident ID, and then you can then feed that right back into the system, and now your analyst or whoever's taking over at the next shift knows, oh, I've now got some new incident IDs that I need to worry about. But luckily, because we have this, in this, what I would call sort of like island structure, I can actually ignore any alert that lands in the blue and the green, right? So the blue and the green is safe, and we can actually make that precise. So, this is what won the challenge, right? We were able to basically ignore 97% of the space, and that was the reduction that we got through the AI graph thinking system. Now, can it get easier? As I've said, Louie, we're really trying to make this super fast and easy here. Louie comes with a lot of great features like trace lines that allow you to see exactly what's happening, full introspection on models, code generation, and other things. Now, has anybody heard of Databricks' Genie? Yeah. So everybody's sort of obviously getting to the point now where they understand the power of LLMs, right? So before we were able to put in, we were able to build notebooks, share notebooks, and that was an incredible first step, right? I don't have to worry about Conda environments or these types of things. But with LLMs now, we're actually getting to a point now where the LLM understands what's happening in the notebook. So same thing with the SOC analyst struggle. Investigations take a tree structure. There's a lot of places that you go down and then you hit a roadblock and it doesn't really work, and then you take a step back and so on and so forth. Through agentic OS and LLMs, you're actually able to now think of that system as a multi-agent system and learn from those progressions. So imagine now, I guess it's kind of scary from the perspective of just AI is using us in some sense, but you're able to now put in your knowledge and expertise within a system and actually have that become a reusable resource within that system. So again, like there's so much context and expertise. There might be people on the team that are really good at some parts of the analysis, et cetera. And we can actually take those steps and put them together in one cohesive system so that the next time you want to run an analysis, you can actually just say, hey, run the AVR analysis, right? And then it'll say, oh, the steps to that are X, Y, and Z. Is that what you want? And then you can tailor make it. So this is sort of, we're kind of coming into the age of these fuzzy pipelines where it has this prior knowledge that was built out, and now you're able to then, having built out these small steps, you're able to now get to the end result, which is the plan, right? The plan is, I want to make sure that the alerts that I'm seeing here are properly binned, properly handled in the right way. So, there's a lot of other features here that we're talking about. A lot of teams use us. We have full map capability. We have question answering. We have a lot of these things that make it possible for you to come in and really slice and dice the data in a single view. So if you're interested in learning more about that, come to the table afterwards. I put the table where that gentleman is sitting. I put a bunch of stickers. He's showing them right now. Thank you. And we can talk more about that. So again, thank you guys all. The takeaways here really are that we're getting to this authoring stack first. We're going to be able to have systems and tools that are learning from the expertise in the crowd, and we're going to be able to pull those back in and turn them into pipelines, dashboards, and so on. There's really interesting work right now in these learning loops. So if you guys have suggestions or interest in that, talk to me. And as this Cybercom challenge showed, we were able to not only win it, but really move the needle there and reduce the amount of alerts by 97%, right? So you imagine a team is coming in and they're getting alerts all day. They can actually ignore it now because they can just look at the part of the graph and they have a certain amount of confidence that they know that anything that lands there is probably going to be okay, and I should focus on the stuff that were the different behaviors outside of that. Try out Graphistry, pip install PyGraphistry in your flows. There's a small registration. It's free, so you guys can get your own GPU accelerated instance and try it out. Thank you.